I think, yes, I remember now, KJ, we were talking about the
Yeah.
parallel plates and the field between them. Physics, part 4, lecture 2. Hopefully on the right slide. Okay, so we're going to have a look at different formulae for electric fields. Okay, so let's see. You wrote this down last time. We started this last time, and we did. We looked at the 4 different fields, or rather the 4 different configurations. So you can have a point charge, and then nearly the same thing is the spherical charge, and then we can have the parallel plates, and then we can have the dipole. Yeah, so this is what we did. And we did equipotential. I think this is where we finished, wasn't it?
Yeah.
Okay, so when a current is passed through 2 conducting plates, separated a small distance d, and with a potential difference of V, it produces an electric field. So if you have 2 plates, one here, and you pass a voltage, a current through it, so that the distance is d and the voltage is V, then the electric field that's produced has a strength of V over D, which kind of makes sense. If you increase the voltage, the field is stronger. If you decrease the distance between the plates, you make the field stronger. If you make the distance smaller, you make the field stronger. It's like you're concentrating the field nearly. So you will definitely need this formula, this definition.
You know.
Too hot. Too hot.
Yeah.
Goodness sake.
Too cold.
Would you like my sweater? Are you okay? Are you sure? I can put it around you. It's okay? Okay.
Hot.
Okay.
Okay.
Want some hot chocolate? No? Okay.
I have my nap.
Oh, good.
Monday to.
Got that? Bruce, what are you saying? Okay, but it's good practice for your English, you know?
Yeah, good English.
Yeah. Okay, continue.
No.
Okay.
So this is about
Yeah, but that's okay because Sean is practicing his English.
Yeah.
Yes. His reading and his writing.
Fine. I mean,
Okay. Yeah.
Sour.
5 words. Okay. We're all waiting for Jerry. No.
Teacher, because I talked to you.
No, don't blame me. Don't blame me. Do you have it now? Okay. So, that was for the plates. Now what about for the point or the sphere? So when you have a charge Q, it will make an electric field. Now what's different about the charge inside of the plates? The electric field gets weaker when you move further away. Makes sense, obviously. So as you move further away from the field, from the charge, the field gets weaker. So it won't surprise you to see the formula is like this. The R squared is down below, because the bigger the R, the weaker the field, because you're further away. The charge is on the top, and this here, this is just a constant,
It's 4 pi
epsilon.
That's E initially.
No, this is a physics constant, okay? Now, the value of E0 is 8.85 times 10 to the minus 12, and we'll work out what the units are for the moment.
What is that?
Huh?
So,
The letter is epsilon, it's a Greek letter. It is just a constant in the formula, okay? It's just a constant. There's nothing really special about it. Well, no, there is a meaning that's not on this course.
we're gonna learn that in mathematics calculus, but there's
No, we don't do that. We don't do that.
I can't see.
It's just like an E.
E equal.
If you want to know a little bit about the epsilon zero, what happens is, nothing major. What happens is, if you put this charge in a vacuum, it makes an electric field. If you put it into a room that has air in it, it makes an electric field. But because there's air in the room, the electric field will be weaker. And if you put the point charge inside of some plastic, then the electric field will be nearly zero. In other words, the reason for the constant is because the electric charge can be in different materials. For this course, we'll consider the electric charge is always in something that is like a vacuum.
So is it like a resistivity?
It's a bit like a resistivity constant for the field. Different materials will have different constants. So if you want the electric field to be strong, do you want this constant to be big or small? Small. Because if this constant is small, it makes the total big. So I believe the epsilon zero is the smallest value you can have. No, that's actually not true, because I think if you put the charge inside something like a metal, like a piece of iron, actually it would be better than in the vacuum. Okay, as a small exercise, as practice from semester 1, take 1 minute to figure out what the units should be for epsilon zero. See what the units are for this constant, please.
Almost.
Cool.
Wait, is there resistivity, right?
No, and no.
V.
Oh.
Stop guessing and just work it out.
Teacher, is this formula equal to F over Q?
You can make it equal to F over Q. You would use this one if you knew the charge and the distance, and you would use the other one if you knew the force and the charge. In some cases you will need to use both. Like for example, if you don't know the charge, if you know, say, the force and the distance, the or. Because if you know the F and the or, you can't use this to get the field strength, right? if you notice the F and the R, you couldn't use the other formula, F over Q, so you'd have to, use both together. Let's work it out, yeah. There's no coulombs in there? I thought there should be a... No, oh well, it looks like it'll cancel then, wouldn't it? Yeah. Okay, so the formula is E equals 1 over 4 pi epsilon 0. Oh, and before I continue, the epsilon 0 constant is on your calculator, if you're wondering. Q over R squared. The unit here is newtons per coulomb. Here we don't know the unit, and this is coulombs per meter squared. So I would get Newton meter squared over coulomb squared equals 1 over epsilon 0. So the units are coulomb squared, Newton. No, I got it. Newton, coulomb squared per Newton meter squared, like this. Okay, roughly.
This is for 8.8. We don't need this, right?
Of course we need.
Of course we don't need.
Yeah.
You always need your units. You got that? Yeah.
The definition of plate and point should be that.
I think I'll actually write it like this. It's easier to say. Go on.
The definition of plate and point in V2 is that
The definition of what?
plate.
Plate, yeah. And point, yeah.
We reset it.
Recite it in the exam. You might, but
Okay.
I don't remember them asking it recently. I think, Jerry, it's this one that they would ask more in the exam. The definition of this one.
Oh, it's fine. I lost it.
You got it?
I lost it.
You lost it, okay. Just before continuing, because this is a constant in the formula, often people just write it as a capital K. Yeah, just stands for a constant, okay? Right, continuing now. So here's our first example. Two horizontal plates have a potential difference of 200 volts across them. The positive plate is 1 centimeter above the negative plate. How long would it take half a milligram particle of charge 10 to the 10 E for your, what was it? It's the one on the calculator, the 1 point, the electron and the proton charge value. So you have here 2 plates. And you know the voltage, and do I tell you the distance? I tell you the distance. So can you know the electric field strength?
Yes.
Yes. And so can you know the force?
Yes.
And so can you know the acceleration?
If we know the force.
If you know the force and you know the mass, which you do know the mass, so can you know the acceleration? Yes. And if it starts at rest and you know the distance and you know the acceleration, then can you know the time? Of course. Of course. So I'll give you a minute to try this. Well, maybe more than 1 minute. We did something like this last time, remember? Except in the one we did last time, I gave you the time. Now I want you to calculate the time. I'm expecting the time to be very, very small. Because the voltage is so strong, I picture the force being so strong, which means it will move down quickly. So you should get a very small time, maybe even nanoseconds. Well, microseconds maybe.
Sure.
Yeah.
What is R? I mean,
The distance. Sorry, if you didn't know that from the last one. In the last one, it's the electric field strength when you're a distance or away from the charge. So it decreases as you move out. The field is weaker. Whereas the one you're doing now, the plates, the field is strength, I think, is equal throughout. It's a bit like a gravitational. It's like a bit like gravity.
okay.
Alright, try this one. Yeah.
Oh. Teacher, is that formula include Q over R square?
This, wait, for this question?
Yes, no, you give us the formula. 1 over 4 pi.
No. You need the other formula because it's moving between two plates.
It is at E equal to
You need that as well. And E equals V over D.
what we know.
Yeah?
Oh.
Definition.
B over D. Okay. Sure. What should I do if I know the acceleration?
I have no idea what you mean. What do you mean, what should you do if you know the acceleration? That's a good thing.
I work out the acceleration.
Good.
And what should I do?
Oh, well, what am I asking for? I'm asking for how long to fall, the time.
Yeah.
What's the number?
Which formula I should apply?
U is 0. S is 0.01.
Oh, okay. Oh, okay.
Yeah?
I followed the phone.
Yes, please. Have you not got it in your notebook somewhere?
Teacher,
It's a lot of.
Yes.
We will get the same so if you use E equal to 1 over 4 times E0 and we use R as the D.
Oh.
The D as R.
If you do get the same answer, it's only through sheer dumb luck. It should not be the same, because that is the field created by a single point charge. But this is a field created by two charged plates. Quite different.
Sure, do we calculate a ring, big G? You have like
In this question?
like S minus big G equal M.
In that way, as we have the UT
What's big G?
plus 1 over
MG.
2 over
Big G.
Oh, should you include the MG? Now you should, but you don't need to because it's so small compared to the other force. The reason, Jerry, is because this is so small. The mass. If this mass was maybe like 1 gram, you know, maybe.
plus 2
How much?
How long have I done it?
Oh, come on, guys. You got an answer? What did you get for your time?
I
0.018.
got 0.95.
That sounds actually too big.
Oh, really?
Sounds actually much too big. 0.018. Could be that, but even that sounds a little bit too big. It only has to fall a centimetre. What halves? It might be that. That answer is more likely to be right than 0.5. Sorry, Andrew. Anyone else got an answer? Nearly? Okay. Did you include gravity or not? Yeah, you didn't really need to, but it's okay if you do. Who else has an answer for me? Bruce, you have an answer?
No, I
It confused you. Okay.
1.58.
No. Well, continue. Times 10.
Multiply 10 to the power 12. Minus 12.
Okay. Minus 12 is better than 12. I thought you were saying 12. That sounds believable. Let's have a look.
Oh!
Okay, hurry up. I'll just draw the picture, okay? Alright. So, on the top is the positive plate. And on the bottom is the negative plate. And here's the charge here. This distance is 1 centimetre. And there's a 200 volt potential difference here. And this is 10 to the 10 E. And it's half a milligram. And there are exactly two forces acting here. There's the force from the field, which is QE, and there's the force from the gravity, which is mg. Although, if you didn't consider the mg, that is okay, because it is so small compared to this. It doesn't actually matter. I will include it for the moment. Okay.
Can you do it the other way?
What other way around?
Which is not included.
Why? What? But it's better, KJ.
I thought it was this one.
I know, but if I do it where I include the mg, then it just means at the end I need to make it 0, and I can do it both ways. Whereas if I don't include the mg and I wanted to know what happens if I have the mg, I have to do everything again. So by including it now, I can discard it later. By discarding it now, I can't include it later. Yeah. Okay. F, which equals ma, which equals QE plus mg. So A equals QE plus mg over m. Now, do we know the E? No, but we have this formula. E is V over D. So this is QB over D plus mg over m. So that is QB over md plus
GP over
G. Is this okay? Yeah?
GD.
No.
Yeah, GD.
No.
Why no?
Why yes?
Look, what is it?
I divide this by m and divide this by m.
Oh, we do divide that.
Yes. See?
I thought we move.
No, we divide. This is the A.
Teacher,
Yes?
why is it QE plus mg? That doesn't mean mg minus QE.
No, the force is acting down because this is a positive charge. Okay, continuing. So, the A, this Q is 10 to the 10 E, and the V is 200, and the M is, what do they say, half a milligram, which is 10 to the minus 6 kilograms.
6.
Yeah,
6. Yes.
And then the distance is 10 to the minus 2, the centimetre, plus 9.81. Now, I think this answer here will be huge compared to 9.81. Yeah, let's calculate it. 10 power 10 whoops. What do you mean by no? You forgot the E? Now don't. Careful. Okay. What's the last one? 10 power plus 9.81. Now, that's not that huge. No, that's not the answer.
73.9.
So I really should include the 9.81. Well, 9.81 is quite large compared to the 60. Like, I thought I was going to get an answer here of like 6,000 or something, not 60. So I definitely need to include the 9.81, I'm afraid. Okay. I'm sorry, okay? I guess half a milligram is big enough.
That makes me wrong, yeah.
73.89.
Yeah.
Now, what formula will we use? V squared? No, yeah. S equals UT, which is 0, a half AT squared. So the T is 2S over A square root. Okay. So square root 2S over our answer.
0.165.
Sorry, Jerry. Good job. So you got like 0.15, was it? Yeah, okay.
Oh, I get 0.019 at first, because I put the minus.
16.5 milliseconds. No, you're definitely the one closest to the right answer, so good job. Okay, 16.5 milliseconds. Yeah, oh yeah. And Jerry, we already know, or KJ, we already know the answer if we leave out the mg, because that's what you got, Monica, which is 10.8 milliseconds, or 18 milliseconds. Okay, so 1.5 millisecond difference. Oh, even less than. Okay, 17.6 compared to 16.5 is just 1.1 milliseconds.
Teacher,
Yeah.
how do we know the direction? It's all
Yes, I tell you, the positive plate's on the top, the negative plate's on the bottom, and the charge is a positive.
Oh, okay.
So the force, it has to be pulling it down to the negative plate. You shouldn't have gotten an answer, because if you have it going up, then the particle never reaches the bottom.
Yeah. No. Okay.
Did you get an answer of like 18.5 milliseconds?
19. Yeah, kinda.
Yeah.
Okay.
Alright, continue? No, I still see people writing. Come on, guys, can we? Not yet? Okay.
I'm so tired. I have 4 periods in the afternoon.
What have you got after this class?
Physics and chemistry. It's okay.
You're back with the science students or chemistry?
Yes.
Oh, so your chemistry class after this is the small group, not a large group?
Yeah.
Oh, you're not mixed in with the medicine students, no? Oh, okay.
We can mix with the semester.
You wouldn't want to. They're not that interesting.
I'm sure they are.
Are you listening, guys?
You don't teach them, right?
I teach them physics.
Oh, how do they?
How are they?
Oh, they're so boring. Why?
You should.
Because they're both partly.
They just started. It'll take a while. Yeah. I don't know who the weirdos are yet. You see. Okay. Maybe not possible. Yeah. Continue now. Yeah. So now here we go. You have an electron is 2 millimeters away from 3 protons. What is the force felt by the electron? So which formula do we need here? What type of field is made by 3 protons? The other one, the point charge, the spherical one. Do you know the distance? It's 2 millimeters. Yeah. Now, in the formula, what is the Q? Is it 3 protons or the 1 electron?
Electron. I mean the electron.
No, it's the 3 protons. Yes, because that is the thing that is making the field that is pulling in the electron.
But last time I did the same question, you told me the charge is the charge that's moving, which is the electron.
Yeah, that was for the other formula. Keep up, man.
Oh shit.
So for this formula, it's the charge, the Q in it, is what is causing the field. In this case, caused by 3 protons. Yeah. Yeah. Okay. I'll give you a minute to try this one as well. Let's practice using the other formula. Okay, I should fix this a little bit blurry.
Bigger.
This is it.
Yeah. 2.
Yeah, do you want me to draw the picture, Sean? It's like this. You have...
Oh, yes, I know. Yes.
Okay, well, I'll draw it anyways.
Yeah.
Proton, 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 and then electron. And the field is like this.
Yeah. But the 2...
And this will move in. There'll be a force moving this in.
Yeah.
Yeah. Okay, so I want to know what is the force. Yeah. Yeah, you got it?
What is the charge for P?
The same as for E, except a different sign.
Okay. easier function. It's a fixed number, like calculator before that.
Have we got answers yet?
1.73 or 3 and 10 negative 72 wrong? What the hell?
What you got, Monica?
Yeah.
Let's have a look. So my formula for F is Q over E. Oh, what am I saying, dude? Sorry, QE. Thank you. Now, which Q is this? Is it the 1 electron or the 3 protons?
Electron.
It is the 1 electron because of the point you just said earlier. Now, do we know the electric field strength? No, but we can work it out. It's 1 over 4 pi epsilon 0. Oh, sorry, what was the distance? 2 millimeters, wasn't it?
0.
That's 10 to the minus 3 squared.
Yeah.
So minus 6.
Huh?
Yep. And on the top I have the charge. And what's the charge on the top? Is it 1 or 3?
3.
3.
3. Yeah, because it was 10 minus 3 squared. Oh, was there 2?
No.
Oh yeah, thank you. There's 2 millimeters. Yeah, no. As Bruce said, I thought it was 1 millimeter. It's 2 millimeters. So I need a 2 times 10 to the minus 3 squared. And on the top, I need a 3e.
3p, yeah.
So this will equal, let me see, 3e squared over 4 pi epsilon 0 times 1 over 4 times 10 to the minus 6. Or if you want, that's 3e squared over 16 pi epsilon 0 times 10 to the 6. And I'll just hit this in on the calculator. Three E squared over 16. What constant, please? What number is E? 22. Thank you.
42.
Oops. 32. Thank you. Times 10 to the 6. This is the force. Yeah, this is similar to what you said. 10 to the... Oh, this is what you said. 1.1.
Yeah, it's something.
Oh, it's okay.
1.73. Yeah. Newtons towards the 3 protons. V over D is when you have 2 plates. This one is when you have a point charge. Is that okay?
Yeah.
I think in both examples, did I need to use this formula? Yeah, so I kind of always need to use that. It's what do I use to get the E, the electric field strength. Yeah. Okay, continue.
Right.
Okay. You're so weak. You just had lunch. And some of you had good lunch, I know.
We just had lunch.
How about me? I do not have lunch.
Really?
Only have later.
That sandwich has been sitting there all morning.
Yeah. Oh, you can.
Two kinds. You don't like it?
No.
Oh, okay. That's all you need is half the sandwich? Ah.
I don't even have too much.
I didn't know. I
So which one?
Of course. Continue? KJ? Are you sure? Yeah? Okay. Let's have a look at the questions now.
Wow.
Okay. I judge by your reaction. That's funny because I'm trying to prepare you for an exam. So, I think you probably, before you start this, would like to take a break, huh? Yes, and then I haven't got time this week. I have to print it out maybe later in the week or next week. I just have zero time this week. Take a break, and then when you come back, get started on these. And I would like to do the answers today as well. So we can either take turns, or you can try them all, and then I'll do them all. Trust you? I trust you. Okay.
I don't really.